Hello, hi. You are welcome to our class for today. We are still looking at measurement. Today we are going to look at measurement in physics, and we'll be looking at measurement of volumes, mass, weight, and time. Measurement of volumes, mass, weight, and time. So this is physics video tutorial powered by Noble Mind Science Tutors Online. I remain Otobo Michael, and you are welcome to our class for today. But before we continue, please try as much as possible to get your writing materials, and then so that you can follow through with the class. If you have not subscribed to this channel or you are just visiting, please, this is a video class on physics, and our intent is to bring your classroom to your doorstep or to your homes, so that anywhere you are, you can learn. Your learning should not be restricted to only when you go to the class. So that is what we have done. So please subscribe to this channel, click on the notification button. If you like what we are doing, please encourage us by giving us a thumbs up. Then if you have any comment, put it on the comment section below. You will also be having some tests or review questions. So our review questions, you can put your answers on also on the comment below. So invite your friends so that they can come and enjoy what you are enjoying now. So right away, we are going to our class for today. So for this class, we are going to look at measurement of volume, mass, weight, and time. So how do you measure the volume of objects? So for the volume of a regular shape, if you have a regular shape, maybe like a rectangular box, if you have a rectangular box, the volume will be the volume of a rectangular box or of a regular shape is given by the length times the breadth times the height. That is length times breadth times height. So assuming you have a rectangular box like this, and then maybe the height is equal to say 15 centimeters. Okay, say 15 centimeters, that's the height. Okay, let me put it here so that right. So assuming this height here is 15 centimeters, just take it out. Then maybe the width here is 5 centimeters, and the length is 10 centimeters. Okay, centimeters. So the volume of this shape will given to volume of this shape with length times breadth times height in centimeter cubes. So you can just do that multiplication. You have 15 times 10 times 5. So what you have here will give you the volume of this chip, and this will be equals to 750 centimeters cube. So the volume of a regular shape, like a rectangular box, this is how you look for it. And assuming you have a cuboid or a cube, okay, you know that in a cube the sides are equal. So if one side is known, you can just use to get the total volume of the cube. So like in this cube now, if one side of it is 10 centimeters, it means that the volume of this cube will be equal to 10 raised to power 3, or to be equals to 10 times 10 times 10. That gives you 1000 centimeter cube. So this is how to find the volume of a regular shape. A cube or a rectangular box is a regular shape. So simply, I think this is your normal mathematics. This is your normal mathematics. So this should not be difficult, but I want you to know that in physics, you also carry out this type of measurement. That is why we are treating it. You also carry out this type of measurement. That's why we are treating it. Okay, so if you have an irregular shape, how do you find the volume of an irregular shape? Now, for you to look for the volume of an irregular shape, the first thing you will do is that you get your cylinder, your measuring cylinder, right? You fill it to half level with water. You fill it to half level of water. Then you take the initial volume, that is V1. Take the initial reading, the initial volume. Like in this case, let's say this is 15, 16, 17. So assuming this is 17, that is your V1. The initial volume of the water, say, is 17 centimeters. So you can take that down, say V1 is 17 centimeters, initial reading. Then you now use a string or a rope to suspend the irregular shape that you want to find the volume inside the measuring cylinder, inside the water on the measuring cylinder. You know that this object that you suspend inside the water will displace its own weight of the volume of water. If you have studied Archimedes' principle, you will know that Archimedes' principle states that an object that is wholly or partially immersed in water or in any liquid or fluid will displace its own weight of that fluid. So this particular irregular shape will displace its own volume of the water, right? And that will lead to the rise of the volume of this water. So in this case now, see the final volume, let's say it's about 20 centimeters. So you can take that would be your V2 to be 20 V2 to be 20 centimeters. Okay, so the volume of this irregular shape now can be gotten from the difference between these two volumes. So the difference between these two volumes is 20 minus 17. So that gives you 3 centimeters cube. So this is how to find the volume of an irregular shape. Any shape that is not regular, this is how to find the volume, and then this is the equation, right? So it is final volume minus initial volume. That is how you find the volume of an irregular shape. So I hope this is quite simple. Okay, so there are other objects too that you need to know how to find that volume. Basically, this is your basic mathematics. Under geometry, you study the sphere, and you also study how to find the volume of a sphere. So the volume of a sphere is given by 4/3 pi radius cube. 4/3 pi radius cube. So if you know the radius, like in this case now, the radius is 5 meters, or assuming you are given the diameter, for you to get the radius, you have to divide the diameter by 2. You have to divide the diameter by 2 for you to get the radius. You divide the diameter by 2, right? That will give you the radius. So once you know the radius, you know the value of pi. Pi is 22/7. Pi is 22/7. 22/7. 22/7, or 3.14, as the case may be. So you substitute the value of pi and then the value of your radius into this equation, and quite easily you get the volume of your sphere. You only just remember that the volume of your sphere is given by 4/3 pi radius cube. 4/3 pi radius cube. So if you substitute these values, pi 3.14, radius is 5 in this particular case. So if you have that, you can easily find the value for the volume of this sphere. I think this is quite simple. This is your normal mathematics. Similarly too, you can also find the volume of a cylinder. The volume of a cylinder, right? Or the volume of a cylindrical wire. If you know the diameter and then the height or the length of the wire, the formula is pi radius square or pi radius square h, as the case may be. Your pi is known. Your pi is 3. Depend on which you are using, but you still give you the same answer, 22/7. That's your pi. So in this case now, your radius is 6 squared. So you can have that. You have 6 times 6. Then you multiply it by the height times 12. So whatever you solve from here will give you the volume of the sphere. To give you the volume of the sphere, as I've said before, if you are given the diameter, divide the diameter by 2 to get your radius. Divide diameter by 2 to get your radius. So that is how to find the volume of a sphere and then the volume of a cylindrical wire or of any cylindrical chip. So now we are going to mass. So what is mass? Mass is defined as the quantity of matter in a body. Quantity of matter, that is the amount of material in a body, that is the mass, and the standard unit for mass is kg, right? It is kg, that is the standard unit of mass, but you can also measure very small mass, you can measure them in gram, but the standard unit for mass is kg. So there are instruments that you use to measure mass. You have the chemical balance, you have the beam balance. So depending on what you have in your own school laboratory, many laboratory they have the chemical balance. The beam balance is not that common, but you see the chemical balance. So this is just okay. So these are the pictures of the beam balance and then the chemical balance. The accuracy of the beam balance is 0.001 gram. That is the accuracy. So these are the machines or the instruments that are used to measure mass in the laboratory. Now for you to do the measurement of mass, you are going to measure the mass against a known weight. You compare the mass of the object you want to measure against a known weight. So assuming you want to use the beam balance is mostly used to measure the mass of chemical. Like you want to weigh out a salt in the laboratory, you can use a beam balance. So if you want to weigh out a salt that is 5 gram, you put a 5 gram weigh on one of the arm, then begin to add your salt to your pan on the other arm until the lever here balances. Once it balances to 5 gram, which is the known weight, you know that what you have measured there is equals to 5 gram. This is the meter. You know that it's 5 grams. So from there you now take your weight. Same thing too with the chemical balance. The two works with the same principles of levers. So this is your known weight, then you add your unknown weight until it balances on this lever. Once it balances, you know that this weight is equal to this. You now take your readings. So that is how to measure mass in the laboratory. You can either use your beam balance or your chemical balance to measure mass. Now there's something that you need to take note of, that mass of a body is constant anywhere on the Earth's surface. Mass is constant and it is a scalar quantity. So it has only magnitude, it does not have direction. And also, for you to carry out measurement and for your measurement to be accurate, one, the object you want to measure the mass, you have to wipe it dry. There should be no moisture on it. Then it is not advisable for you to weigh a hot object, because the hot object has expanded, so it will not give you, you will not have the accurate weight of the hot object. You have to allow the object to cool first before you weigh it. That's the precaution that you need to take when you are carrying out weighing of objects. So now, what is weight? Okay, weight is defined as gravitational pull of the earth on a body. Weight is the force of gravity, that is the gravitational pull of the earth on a body. That is the weight. So you find out that weight has to do with force of gravity, but mass has to do with quantity of matter that is in a body. You know, sometimes this is always confusing students. The two are different. Mass is a scalar quantity, while weight is a vector quantity, because it has both magnitude and direction. Now the standard unit for weight is the Newton. So that tells you that weight is a force. It is a force that pulls us down. So the standard unit for weight is the force, or is the Newton, which is also equal to the unit for force. And weight mostly is measured with a spring balance. So this is a picture of a spring balance. When you add your weight to the spring balance, you see the lever on the spring balance begin to move until it balances. Once it balances, you take a weight from there. So weight is a vector quantity, and one thing you need to take note of is that weight varies from place to place on the Earth's surface. This is a major difference between mass and weight that you need to take note of. These are questions that is set in objective in WAEC, JAM and all that. So just take note of this, that weight varies from point to point on the Earth's surface, but mass remains constant. Mass does not vary because mass does not depend on gravitational force, but weight depends on gravitational force. Okay, weight depends on gravitational force, but mass does not depend on gravitational. Weight is given by mass times g. This is acceleration due to gravity, and this is mass. This is weight. So weight is a force. Weight has to do with force of gravity. So that is why weight varies from point to point, but mass remains constant. Alright, so this is another quantity that we need to measure, and that is time. Measurement of time is very important. You need to know time at every point in time. So what is time? Time is defined as the interval between two successive events, right? The interval between two successive events is known as time, and the unit for measuring time is the second. We can also measure time in minutes, hours, day, week, month, or year, but the standard unit of measurement of time is the second. And the device that is mostly used in the laboratory is a stop clock. It is a stop clock that is used to measure time in the laboratory. So basically this is what is used to measure time. You also have your wristwatch. Okay, you have your wristwatch. You use your wristwatch to measure time, but in the lab we use this stop clock to measure time in the laboratory. So you need to familiarize yourself with this simple time relationship: 60 seconds, 1 minute, 60 minutes, 1 hour, 20. This one you need to familiarize yourself with them, because sometimes you might have some calculations that you you need to do some little time conversion and you get a little bit confused. So familiarize yourself with this simple relationship or time and seconds, minutes, hours, and days. Okay, so I just mentioned some differences between mass and weight. So this is just like a summary of the difference between mass and weight. Please, you need to take note of this, especially the third bullet point. Okay, especially this third bullet point and the fourth one, should take note of them. Mass is constant. Weight varies from place to place on the Earth's surface. That's a major difference between mass and weight. So mass is measured in kg, weight is measured in Newton. Mass is measured using a chemical or B balance. Weight is measured using a spring balance. Mass is constant. Weight varies from place to place on the Earth's surface. Mass is a scalar quantity. Weight is a vector. Mass is a fundamental quantity. This is another good difference. Weight is a derived quantity. So basically, these are the differences between mass and weight. These are the difference between mass and weight. In our next class, we will study the relationship between mass and weight. Relationship between mass and weight. So this is where we are going to end our class for today. This is where we are ending our class for today. Thank you so much for your time. Please do a review and take down your notes. Take down your notes. Please don't trivialize this class. Take down your notes and make sure that you know the difference between mass and weight. In our next class, as I said, we are going to study the relationship between mass and weight. Relationship between mass and weight. Okay guys, so this is where we are ending our class for today. If you have not subscribed to this channel, please subscribe to this channel, tell your friends, and click on the notification button so that when we upload a new video, YouTube will notify you. Also, give us a thumbs up if you like what we are doing, because the best is yet to come. The best is yet to come. Also, put your comment on the comment section below. Put your comment on the comment section below. So, thank you for your time and see you in our next class.